So now we want to run through some of the properties we learned about logarithms. It will take a while to get used to logarithms, but it takes some practice to understand the notation, the meaning of it, look at its graph, start solving some equations. Okay. So the first one we have is just really the most basic of it, which is rewrite using log notation. So again, keep in mind the idea is we introduced log notation because we were looking for the inverse of an exponential. Okay, so this is base 4 exponential, base 2 exponential, and base 3. Okay, so all those we convert, we don't change the base. The base stays the same. The only thing we switch, right, remember when we do inverses, is input-output. Okay, so in this case, when we switch to logarithms, it will be log base 4. Okay, now keep in mind here, you inputted 3, you outputted 64, so when we do the inverse, we input 64 and output 3. And this is base 2 for the exponential, so it's still base 2 for the log. Switch input output. So 32 came out, so 32 goes in, and 5 comes out. Okay. And the last one, and it's log base 3. Okay, we inputted -4, it outputted 1 over 81, so we switch the rows of the inputs and outputs. All right, next set are just 3 equations to solve. Now, there's a lot of different kinds of logarithmic equations that we're going to need to solve. These are sort of the basic ones. It's just log of something equal to a number. Okay, there's not multiple logs, there's not exponentials buried in here. So it's really the simplest of the equations. And again, there's other ways to solve these, and we learn more methods as we go forward. But for these, I'm going to do exactly what we did before, but in the reverse. So if you remember on the first page we had exponentials, so we switched to logs. We'll take these logs and switch to exponentials. Okay, but again, the base doesn't change. Okay. So when I want to switch this to an exponential, it's still base 8. Okay. For the logarithmic equation, in went 4, out goes x. So for the exponential, in goes x, out comes 4. Okay. Now, fortunately, this is now an exponential equation, but we should know how to solve this. We could certainly write 8 and 4 both in base 2. So we write 8 as 2 cubed, so that x power. Rewrite 4 as 2 squared. Okay, so this is one of your more basic ideas about solving exponentials, when you can write both bases the same. Okay, so power to the power, that would just be 2 to the 3x, that's 2 squared. And then you can set the exponents equal to each other. And you get 2/3. Okay. Similarly here, and again, there's other methods. We're just going to rewrite as an exponential. So it's base x, now to the 4th power, is 32. Okay, keep in mind this is not an exponential equation, right? The x is not in the exponent. Okay, it's just a 4th power. So we take a 4th root on each side. And x equals the 4th root of 32. Okay, remember, bases have to be positive. And then the third one, again, it's base 2. So it's exponential with the base 2 to the power of -3 equals x. Okay, so this is already solved for. 1 over 2 to the -3 is 1 over 2 cubed, or 1/8. All right, so now we're going to do some rewriting. Notice these are not equations anymore. These are just expressions that we want to write in a different way. Okay, and again, just sort of depending on if we're trying to solve an equation, what we need to do, we want to be able to rewrite these in different ways. Okay, but again, these are just expressions. We're going to try to write it as an equivalent expression. Okay, we had a few log properties. Okay, one deals with products and quotients. Okay, and then we have some with powers. Okay, so remember the log of a product is the sum, so it becomes log 8 plus log x. Notice the base does not change. So remember, this is base 10, so these would still be base 10s. Okay. Quotient, remember, becomes a difference. So it's the log base 2 of the numerator minus the log base 2 of the denominator. There's no products and quotients down here right away, but this it can be a power. So remember, back to base 10, but 8, square root of 8, we could write as 8 to the 1/2, and then we know we can bring that power down in front. That's another one of your log properties you need to know. Okay. This one, it's not clear what you might be able to do with this, just log of a number, okay? But it is log of 1/10. And since this is log base 10, we should be able to figure out a way to clean this up a little bit. Now I'm going to choose to write it in fraction form, because then I can write it just like I did in number 2 as log of the numerator minus log of the denominator. Okay, and fortunately these are two we know. Right? It doesn't matter what the base is. Remember, this is base 10. Log base 10 of 1 is 0, 0 minus log base, remember this is base 10 when the base is matched, that's 1. So we get negative 1. Okay. All right, just a couple more. Another property, right? When you have exponentials and logs inside one another, then it's likely that they can be simplified. Okay, so 2 to the log base 2 of 7, remember, what does that mean? It means I'm taking 7, I'm putting it into the log base 2 function, but then I'm exponentialing it. Okay, well, that means you're going to get back to 7. All right, 6. Again, it's a fraction. Now, again, we have to be careful because there is a product on the bottom, but we have to separate the fraction first. So log of the numerator minus log of the denominator. Making this natural log, which is log base e. Our properties work with any base. Not much I can do here, but I can separate the product. Now, again, you're just going to be careful because you'll need to introduce this bracket. So it's log of the first plus log of the second, because that minus needs to get distributed. So you could leave it like this or distribute the minus. And then the last one just has a bit more in here. Now, again, keep in mind for roots, you want to switch it to an exponent. The 1/2 power. So we can't get in here until we get rid of the 1/2. So we bring down the 1/2. We can't get inside the numerator or into any of those powers until we separate the fraction. Okay, so we do, and again, be careful. You have to introduce a bracket because you're going to put a subtraction in. So it's the log of the numerator minus the log of the denominator. Okay, now I can get at this power, but let me deal with this first. I have a product. You can't get at that 3 or 5 until these get split apart. So it's the log of x cubed, remember, plus the log of y to the 5th. Still have this. And now we can bring down each of those powers. So we have 3 ln x plus 5 ln y minus 4 ln z. Okay, now what's better, this or this? It sort of depends on what we're trying to do. Okay, so we just need to be able to write it in either form. Okay. All right, here we're doing the reverse, right? Because we want to put it all together. Okay, so we're going to try to write it as a single logarithm. Okay, well, we know what to do with addition and subtraction, so I'm going to do it sort of in order here. So I'm going to take these two. The sum of two logs, remember, becomes the log of a product. Still have this. When you have log minus log, remember that becomes a quotient. So I'm going to write x plus 2 over the 2. Okay, and you can put it all together into a single log, which again is sometimes the form we want. Okay. This is not log minus log, it's 2 log minus 3 log. So you have some work to do. So you got to bring that 2 up back as a power of n. You have to bring 3 up as a power of n. Now it's log minus log, right? And we can combine those into a single log divided. Similarly here we have powers to bring up. So I'll do ln of p to the 1/2 plus ln of 2p to the 3/2. This one has no coefficient, so we're good. Okay. Again, I'll combine these first. This will be ln of p to the 1/2 times 2p to the 3/2. Okay. I'm going to clean this up before we go too far. Okay, so that's ln p to the 1/2, 2 to the 3/2, p to the 3/2. Okay. So I'll combine those p's. So 2 to the 3/2, 1/2 plus 3/2, remember, is 2. Okay. And now finally log minus log can be log of a quotient. So 2 to the 3/2 over m squared p. And just rewrite this one more time, because the p and the p squared will cancel, so I have 2 to the 3 halves, just a single p now on top, over m squared. Okay. These last two, asterisks, right, because we cannot rewrite these. Okay. If it's a log plus a log, we can rewrite. It's a log minus log, we can rewrite, but we have no properties for a log times a log or a log divided by a log.